Okay, so we start off with a 1 meter piece of wire, which we're going to cut into two pieces. One of those pieces may actually have no wire at all. We'll come to that later. One of the pieces will bend into a circle, and the other piece of wire will bend into a square. How should we cut the wire to make sure that the total area of the wire is, and then I give you two possibilities, is as big as possible and as small as possible. We can work on both of these simultaneously. Step one, let's draw ourselves a picture. So here's our 1 meter piece of wire. And at some point, we're going to cut it into two. We'll take this first piece from here to here, and we'll bend that into a circle. We'll take this piece of wire and bend it into a square, so from here to here. So that gets changed into a square. Obviously not drawing quite the scale here. And we want to make this as big as possible and as small as possible. So we have our picture, we have the 1 meter piece of wire, and we're going to bend this part into a circle and this part into a square. So step two, let's come up with our variables. What we have a choice about is where to make this cut. Anywhere from the left-hand side, which is 0, to the right-hand side, which is 1. We're going to make a cut. And so let's call the length of this from 0 up to here, the length of the part we make the circle, let's call this length x. And if we start off with a whole 1 meter piece of wire, that means the length that the part that gets made into a square is 1 minus x. Let's deal with the square first. So if we have 1 minus x total to make a square, then each of these sides is a quarter of that. So each of these sides has length 1 minus x over 4. And this has length 1 minus x over 4. And so does this, and so does this. The length and the width of that square are 1 minus x over 4. Each one of those sides is a quarter of the total length of that wire. So the circumference of this circle is going to be just x. That's how much wire we have. We have x to make the circumference of the circle. But we also know that x is equal to 2 pi times the radius. So let's work out what the radius is in terms of x. So the radius is 2 pi r, and that's x. So let's get r by itself. R equals x divided by 2 pi. So this radius is just x over 2 pi. So let's come up now with, let's also say A is the total area. Let me say it's the area of the circle plus area of the square. Well, we know how to compute the area of a circle. The area of a circle is pi r squared. Pi times the radius squared. I guess I already called the radius r. I could put r in up here, but I'm not going to do that. And then the area of the square, that's easy. That's just 1 minus x over 4 times 1 minus x over 4, length times width. So we said the radius is x over 2 pi. Let's put that in. So pi times x over 2 pi all squared. And if we FOIL out the top and multiply the bottoms, that's how you multiply fractions. You multiply the tops and multiply the bottoms. You end up with 4 times 4 is 16 on the bottom. And I'm going to put my x squared term first. So x minus x times minus x is positive x squared. Then I have a minus x and a minus x. That's minus 2x plus 1. And simplifying over here. So this is just simplification. Again, as usual, as soon as you want, you can change everything into decimals. I'm going to leave it in exact numbers. That's just my own personal prejudice. So I have x squared on top. I have 4 pi squared on the bottom, but a pi on the top, which cancels one of those pi's on the bottom, so that just leaves me 4 pi. Then I have an x squared over 16, a minus 2x over 16, and a plus 1/16. That looks kind of bad, probably already a little bit better than it did. I'm going to collect up like terms. So I have 1 over 4 pi times x squared and 1 over 16 times x squared. So that's 1 over 4 pi plus 1 over 16 times x squared. That takes care of those two terms. And 2 over 16 is 1/8 x plus 1/16. So here everything is a function of x. So I have my function. We have already finished step 3. Now let's go ahead. We don't need to do that step 3.5, like this step 3.5 that we did in the previous problem because we had too many independent variables. All we have is x. That's good. So let's go ahead and come up with our interval. This is particularly easy in this problem. We have this wire all the way from 0 to 1. We're going to make a cut somewhere x, so x is between 0 and 1. And as usual, we'll include the endpoints. Let's talk a bit about what it means for x to be 0 and x to be 1. If we make the cut over here, then every part of the wire is to the right of the cut. And so we don't use any of the wire to make the circle. We use the entire wire to make the square. If we make the cut over here at x equals 1, then the entire part of the wire is to the left of the cut. And so we use it all to make the circle and none to make the square. So that's how that works. So let's go ahead and take our derivative to find our critical points. A prime of x. The 2 comes down and multiplies those two fractions. I'm going to do the multiplication. 2 times 1 over 4 is 1/2. So this is just 1 over 2 pi plus 1/16 times x. The 2 comes, times x to the 1. And then minus 1/8 x to the 0 plus the derivative of a constant is 0. So we'll set a prime of x equal to 0 to get our critical point. So we have all this times x minus 1/8 equals 0. So we have 1 over 2 pi plus 1/16 times x. If I bring this onto the other side, this equals positive 1/8, and I can divide both sides by all that nonsense. And so we end up with x is equal to 1/8 divided by 1 over 2 pi plus 1/16. And at some point, we're going to have to go ahead and use a calculator because we're sort of running out of things we can do without a calculator. But if you really like exact numbers, we can simplify that a little bit. If we multiply the top and the bottom by 8 and pi, you end up with pi divided by, divided by, so 4 plus pi, I guess. Oh yeah, 4 plus pi. And that's about as simple as we can make it without a calculator. But there's no reason to do that. You can just go ahead and use a calculator. Anyway, that number is approximately 0.44. So this approximately equals 0.44. So 44 centimeters in make a cut. So let's go ahead and test both our endpoints, the 0 and the 1, and that 0.44. So x and a, we're going to plug in x equals 0, x equals 1, and x equals 0.44. If you plug in x equals 0 up here, it's pretty easy because that term is 0 and that term is 0. You just get 1/16. But you can use a calculator for that, and you get 0.0625, which is 1/16. If you plug in 1, you'll definitely need a calculator for that. You get 0.0796. And if you plug in 0.44, you get about 0.0350. So in this problem, we're supposed to do both as big as possible and as small as possible. So the biggest of these 3 numbers I see is right here. The smallest of these 3 numbers I see is right here. And let's see, what was the question? What did the question ask? How should we cut the wire? So all we need is x. So to make it as big as possible to make area as big as possible. We're going to cut at x equals 1. In other words, use all the wire for the circle. And to make the area as small as possible, we use 44 centimeters for the circle. And 1 minus 44 centimeters, which is, 56 centimeters for the square. That was a difficult problem in terms of computation, just because the numbers didn't work out beautifully, but other than that, the steps are exactly the same.